All right, welcome. Today, we're going to do something super useful. We're taking a full GCSE Physics question on electromagnetism and picking it apart using the official AQA mark scheme. I'm going to show you exactly what the examiners want to see so you can lock in every single one of those marks.
So let's get right to it. The specific question we're looking at is question 4 from the AQA higher tier paper, the one from June 2019. Honestly, the whole game here is learning to think like an examiner, and that's exactly what we're going to do.
Here's how we're going to break it down. We'll go through each part of the question step by step. We'll start with drawing a magnetic field, then explain some forces, and finish up by looking at some data. And for each part, we'll check out exactly what the mark scheme is looking for.
Okay, let's get started. Remember, this isn't just about knowing the physics. It's about knowing how to present your answer in a way that gives the examiner exactly what they need to tick those boxes.
First up, we've got a 2-mark question that's all about drawing a magnetic field. This is a really common way they test if you can visualize what's happening.
Okay, so here's the solenoid, straight from the exam paper. The question seems simple enough, right? Draw the magnetic field. But before you even pick up your pencil, take a second. What are the 2 absolute must-haves for a perfect answer here?
And here's what the mark scheme says. See, it's split into 2 clear points, one for each mark. You get the first mark just for drawing at least 2 loops inside the solenoid. Easy enough. The second mark comes from drawing at least 1 complete loop outside the solenoid with the direction clearly shown.
Right, that second mark is all about the direction. So how do we figure that out? Well, look closely. The current goes in on the right and comes out on the left. Time to use your trusty right-hand grip rule. If you curl your fingers in the direction of the current, where does your thumb point? To the left. That means the left side is the North Pole. And we know that outside the magnet, field lines always go from north to south. So your arrows have to point from left to right. Nailing that direction is how you bag that second mark.
All right, let's move on to the next part. Question 4.2 is another 2-marker, but this time it's a written explanation about magnetic forces. Let's see what's going on.
So here's the setup. You've got 2 iron rods just sitting inside this coil. The question is, when you flick that switch and the current flows, why do they suddenly jump apart? You need to explain the physics behind it.
Okay, let's see how this breaks down into 2 easy marks. First mark, you just have to state that the current flowing through the coil creates a magnetic field, and this field turns both iron rods into magnets. Simple. For the second mark, you need to explain why they push apart. Since they're sitting in the exact same magnetic field, the sides facing each other will have the same pole. They both become north poles, or both become south poles. And what do like poles do? They repel. The mark scheme is pretty helpful here. They'll also accept if you just say they're magnetized with the same polarity.
Okay, time for something a little different. Part 4.3 tests your understanding of experimental design. Your job is to find the big mistake in a student's method. What makes their results totally invalid?
On the screen, you can see the student's setup and the data they collected. The question asks you to explain why their method is not valid. Take a good look at that table of results. Can you spot the fundamental problem?
And the mark scheme boils it down to this one simple, fatal error. This is it. This is the core reason the experiment doesn't work. Just stating that the student changed 2 variables at once gets you the first mark. It is like the classic mistake you learn to avoid in science.
And for the second mark, you just have to name the 2 things they were changing. If you look at the table, you can see it clearly. For each measurement, they changed both the current and the number of turns of wire. For a fair test, you can only ever change 1 independent variable at a time.
Awesome! We're on the home stretch now. For the last 2 parts, another student has done the experiment the right way, and our job is just to read and interpret the results from their graph. So here's the graph. You can see 3 different lines for 10, 20, and 30 turns of wire. Question 4.4 asks, how does increasing the current affect the strength of the electromagnet when the electromagnet has 30 turns of wire?
This is a nice straightforward 1-marker. All you have to do is describe what you see. Find the line for 30 turns and what happens. As the current along the bottom axis goes up, the strength on the side axis also goes up. That's it. The mark scheme also mentions you could say it is directly proportional up to 2.5 amps, which is a bit more detailed because you can see the graph starts to flatten out after that point.
Okay, for the very last mark, they want us to compare the effect of adding more turns. So let's pick a current, say 2.0 amps, and see what happens. When we go from 10 to 20 turns, the strength jumps up by 5.2 newtons.
But when we go from 20 to 30 turns, it only goes up by 2.2 newtons. See the difference?
And that observation leads us directly to the perfect answer. You simply need to state that the first jump, from 10 to 20 turns, made a bigger difference to the magnet's strength than the second jump, from 20 to 30. It's a question that asks you to compare, so you give a comparative answer.
And there we have it. We've gone through that entire question, from top to bottom, and seen exactly what the examiners are looking for in the mark scheme for every single part.
By breaking down the question and following the logic of the mark scheme, using the right words, and structuring our answers just so, we've confidently picked up all 8 available marks. Well done!
So look, the big takeaway here isn't just about electromagnetism. This whole technique of deconstructing the mark scheme, you can use this for any topic you're studying. Seriously, it's probably one of the most powerful revision tools you've got. So give it a try. Thanks so much for joining me.